Then this is the project information respect to all the towers. Top tower we have then we have middle tower, then we have bottom tower. Then this is the map view. Further going, these are the architecture plans of different towers. This is the top tower architecture plan. We have amenities so and so. We have these are the amenities that we have for the middle tower. Here we have the garbage. Then and this is the bottom tower amenities. And these are the structural plans. This is top tower structure plan. This is middle tower. And this is bottom tower. And we have a zooming portion of the bottom tower. This is upper portion of the bottom tower, and this is the middle portion of the bottom tower. And this is below portion of the bottom tower. Then these are the section properties. These are the section properties.
Okay.
These are the slab sections. These are the shear walls. Then these are the frame loads. These are the area loads that we have come across. Then these are the calculation, the common calculations of the area loads. This is section view of the sentence slab. And OHC we have considered for single tower, we have considered 4 OHCs of A, B, C, D by considering different storage days and considering different number of flights. On an average, we have taken 25 kilonewton per meter square for all the towers on the slab loading of OHC. Then this is LMR calculation. And from now on, our top tower will be taken by Manu.
Thank you, Praveen. Good evening to all.
Good idea.
Next slide, Praveen. Yes, this is the top tower mathematical model. Next. This is the fixed supports of the given in the top tower, and this is the end releases for the top tower. Next, and this is the seismic analysis in which we are taking the IS 1893, and there is the different type of live load that is greater than 3 and less than 3. So we have considered all the parameters. Next slide.
मुर्गेसन मेन जनरल मीटिंग में आ जाओ.
And this is the specifications, that location in Mumbai.
Please come to the general meeting.
And for the top tower, the time period in X is 1.7 and in Y direction 2.5. And for the top tower, the seismic weight is 27790 kilonewton, and for the base shear in X 205.28 kilonewton, and for the Y 2642.995 kilonewton. Next. And this is the wind data in which we have taken the 44 meter per second, and the terrain category is 3, and importance factor we have taken 1, and we are designed for up to the 15 years, and topographical factor is 1. Next slide. And this is the gust forces we have calculated from the Excel sheet. And next slide, please. And this is the model behavior of our structures in which the fundamental time period is 3.687, and rotations we have got in first mode is 5%, and for the second mode we got the up to 1%, and last mode is 15, and we got the total some UX and some UI is up to the 97%, and the time difference between second mode and third mode we got 10%. Next slide. And this is the base shear for the top tower. Next slide, please. And this is the deflection check for the top tower in which we got the 20.35, and after we got the at the supports 19.9 after the taking the creep coefficient 3. Next slide. After taking the creep coefficient 3, then the resultant value is 1.05 mm deflection. So this is safe. Next slide, please. And this is the stability check. In the drift, we got the we are safe in the structures, but in the displacement due to the winds, it is not safe. And displacement due to the arcade, we got the value which is safe. Next slide. And this is the stiffness modification factor for the service. Next slide. And thank you. The further PPT is taken by the Rishikesh.
Thank you, Manish. Hello, everyone. My name is Rishikesh. I am good evening, all of you. Yes. This is the mathematical model of the middle tower. These are the support conditions. Fixed support, we are given the fixed support from the top, bottom top. Then for these are the beam releases for the middle tower. Yeah. These are the seismic analysis in that while we defining the mass load, give a scale factor for live greater than 3.5 and live less than 3.25 according to the IS 18 part 1. These are the planar dimension, length of the building, height of the building, and the width. Then coming to the building specification, then there is we consider the soil type too. Then the response reduction factor we have considered with the 4 because there is a structural wall system in there. And the base shear we have calculated it's in the AX is 522 kilonewton and the BVY is 68170 kilonewton. Then the wind data analysis is there. We consider the basic wind speed is 44 as per the location is, and the terrain category is 3. So based on the dimension according to the IS 875 part 3, they have to consider the windward and leeward position as 0.7 and 0.8 to x 1.4 and 0.1 90 degrees off. And this is the thrust factor calculation is there in Fx and F1 according to the IS 875 part 3, 1987. In the model, coming to the model analysis, the first mode is purely translation. Second mode is also translation is there. And third mode is coming on vacation. But the time period difference between first and second mode is 12.4%, and the second and third mode is 4.1%. It is a quite a mixed mode, and we have to try to control this the behavior of the subject. And there is a deflection check. So the deflection is coming in the lab is 22.479. Yes. So this is the final deflection after subtracting the actual throttling effect and multiplying the three coefficients. The final deflection coming out is 4.266. And actual limit of the deflection is 17.85. So this is that. And the best share for the mid tower is for FX it's 522, FEY is 6817, SpecY is 426, and Spec X is 426, and SpecY is 326. The scale factor we have applied according to that calculation. The best share for wind is also there, 6548 km in X direction and 3427 km in Y direction. And the self rate of the building is coming out 28,000, 2,82,631 km. Then coming to the stability checks, there is a displacement under the safe mode. The displacement due to wind is actually this is the static wind deflection. While we are applying the gust, there is a huge amount of deflection is coming, so I have not put it in the table. So we are working on that part. Displacement due to earthquake is coming in X direction 79.3 mm and in Y direction 113 mm. So it is it. So those are the stiffness modification factors according to service and some model we have applied. And torsional irregularity checks according to the ABC 1997. So I have applied the diagram of computation. These are the software calculations. So according to that, there is no software is present in the structure, but still we are trying to apply it in the ground floor. Yeah. Thank you. The remaining part of the PPT is explained by the professor. Thank you, Rishikesh. Good afternoon, everyone. Good afternoon, sir.
Good afternoon.
Okay, next slide, please. So this is the mathematical model view of the bottom tower portion. Next slide, please. These are the support conditions, fixed support conditions of the bottom tower. Next, these are the end use conditions of the beams. This is the seismic analysis mass source we have taken for the dead load of 100% and 25% for the live load which is less than 3 and 50% for the live load which is greater than 3. And we have considered the fundamental natural time period formula as per 1893 as for the infill wells. Okay, next slide, please. These are the lateral dimensions of the buildings and the height of the buildings we have considered as 125.3 meters from the ground to terrace. These are the seismic parameters we have considered. The time period for the as per IS 1893, which is coming as 2.246, and from the vibration it is coming less 1.63673. The base shear is coming 6849.82 kilonewtons, and it is measured in the y direction. It is 9195.875. The seismic weight we have considered 4713. We have calculated 4713 44.93 kilonewtons. Okay, next slide, please. The wind data is taken for the Mumbai locations. We have considered the coefficients for the wind as 0.7 and 0.8 for the x-axis, and for the perpendicular axis we have taken 0.4 and 0.1 as per one on IS 875 part 3. Okay, next slide, please. Yeah, these are the gust forces which we have applied in the bottom tower case. The maximum force of gust we have got 265.26 kilonewtons at the 40th floor. Okay, next slide. Yes, this is the model analysis results. We have the fundamental time period is coming 3.744 at the and the first mode is completely translation mode in the y direction, and the time period gap for the first mode to second mode is 16.4. But in case of second mode and third mode, we have got the mixed mode, and the time period gap is not achieving up to the mark. We are trying to make it more than 10% as well. The next slide, please. The deflection. This is the deflection checks. We have got maximum deflection for as 24.46 millimeters, and next slide, please. And we got the actual shortening for 21 millimeters. So the net deflection is coming as 7.6, which is very safe as per span by 350 formulation. The limit is 18.71 millimeters. The span we have considered for this is 6.55 meters. Okay. Next slide, please. This is the final base shear. We have the calculations. The self weight of the building is coming as 357418.9 kilonewtons. We have next slide, please. This is the stability checks. The maximum displacement for the gust in the x direction is coming less than 100, and it is 98.78 millimeters, which is safe enough. And for the displacement due to earthquake, which is maximum in the y direction, it is coming 90 millimeters. Hence, it is safe. Okay, next slide, please. These are the stiffness modification factor we have taken for the service crack and strength crack model. And these are the torsional rigidity checks. Next slide. We have got the ratios of more than 1.2 for the from the steel to 6th floor. And next slide. We have applied the eccentricity for this as well. Next slide. Yes, no software are coming. We are opting for applying the software at the ground floor as well. And thank you, sir.
Okay. Okay, is it over? Yes. All the 3 towers, I guess, right? First of all, we have told that it is 45-story building, right? If you remember. Anyway, can we go to the master plan of this? Is it over or hello?
Yes.
Okay.
Okay.
Okay. So can we start with the first plan which somebody yes. See, first of all, you are giving this top tower, middle tower and bottom tower, right? Don't give like top, middle and bottom. It doesn't look professional. You give tower 1, tower 2 and tower 3. That will look a little bit more professional. Okay, it is just the text editing, so I don't think any issue would be there. Okay, this is not for this team one, but it is basically for all the teams. Okay. So T1, T2, T3, tower 1, tower 2, tower 3. So very good demarcations that you are given. Few more things I wanted to tell you over here is that tower 1, tower 2, tower 3, is this the only structure available? No, there is a podium. Do you agree? And everywhere there is a expansion joint. So that thing is missing. And at the same time, as a demarcation, we have to give some kind of columns positioning of the podium areas also. I would like to just show you one that there will be, let's say for example, if this is the line of the expansion joint, this is the tower column, and you will have here as a podium column. This is the podium column. You can have this as a facility, or there is another thing that you can have a column, and on that you will have a corbel, and in which this another slab will be rested, and here there are the joints. We are calling this particular arrangement as the corbel connection. In such cases, you don't need the column here. This beam, suppose if there is a beam coming here, this beam will be directly rested on the column which is given in by the main tower. So either the arrangement, you will have one column one here and another column here. So this is tower column and this is podium column PC1, tower column TC1. So podium column number 1, tower column number 1. So like that, actually the PC numbers, podium column numbers need to be given. No need to give the numbers, but at least the locations, basically where and all it is coming. So
Sorry to interrupt, sir. Hello.
yeah, so macro level, yes, tell me.
Sir, actually we have given the podium column, but in that you specifically mentioned the only typical is
Yeah, no problem. But overall, see what happens, Rishikesh, is we need to understand that this tower is totally separate from structural point of view. This tower is totally separate. Correct? So podium building will come like this. Something like this, and there will be void here and a void here. Because this is tower number 1, this is tower number 2. Whereas all this columns will be coming here. Correct. So in the main presentation, I think this is what I'm feeling that if you can give. Another thing is how many basements are there? Only one basement? Okay. So in the one basement, we don't need any shoring piles. Otherwise, we require some shoring piles here. Do you agree? We don't need it now. Understood. But overall, the presentation, I would like to show from the first presentation. This is the first one? Yes?
Yes.
Okay, can you go to the next one? Please give me the control. Yeah. Thank you. So this is the first thing, that tower 1, 2, 3. See this is what we require. See, this is expansion joint. So these are macro level decisions. Do you agree? This is a good decision that you are taking. But exactly where the expansion joint is coming, that also if you can just mark it here, that which particular grade or something like that would be better. But anyway, this is the first drawing, first sketch. So it's okay at this moment, but yeah, so this is tower number 1. See, architectural plan and all, actually we don't need it. If you are dealing with the BIM technology, project management and all, then we require all this. But In structures, we don't need it. We require the column positioning which you have already given. So please delete the first few slides in this. Okay. Since you have created, it's okay, no problem now. But still, once the structural framing plan should be more creative. I mean, this is what actually I would suggest, that 2 BHK, 5 towers. Anyway, you've given, keep it like that, but generally we don't give that. Now coming to this area, this is okay. Oh, 1 minute, I think I'm going in the wrong direction. Okay. So in this, such a big beam, don't you think something is need to be corrected here? See, I would suggest in such kind of cases, one column here, another column here. Okay, just to reduce the span, this span. Rest, I think many things are perfect. Here I would suggest, okay, this is one column here. We need some window here, I guess.
Yes.
So this is okay, this is okay, this is okay. Perfect. I don't know whosoever has created. It is so nice. This is a lift.
Yes, sir. Fire lift, sir.
Fire lift. If the lift is there, we have to give this opening. Am I right? We cannot give the slab.
Okay. Yes, yes, sir.
Correct. So what I'm suggesting here is, since see here, this is a lift, so it will be the opening here. Correct. The slab mark, please remove it. And since it's a Mumbai project, the generally what happens is wherever there is a shear wall, no, the core, I mean the lift, we have to have, for the lift we have to have something like this. All the three sides there should be the opening. I mean the lift pit or the lift need to be given. RCC wall need to be given at all the slides, all the sides. Okay, what it means that you cannot give the lift like this. It is not possible. Only shear wall here, shear wall here. We have to give the shear wall at all the three sides. One side, two side, three side. All the three sides we have to give the shear wall. Is this the requirement of the structural? No. This is the requirement of the fire engineering. Engineering of HRC. What is HRC? High Rise Committee. Okay, तीनों side पे shear wall चाहिए. Specifically here. Here it is there already, so that is perfect. But here we need to give the cross mark. Correct? You cannot give the slab in the middle of the lift. Am I right?
Yes.
The rest, I think it is okay. Only one change over here, I guess.
So there is the parking, sir. So that is. So say if you provide the shear wall, then parking will be disturbed.
Is it? Okay.
Yes, sir.
Okay, then we need to design that as a deep beam. Just check the span
Yes,
and
sir.
other things.
Better. Yes. Okay, sir.
Okay. So this is the tower number 1. This is the same option here, same thing here. See, I think here you are given, you tried to give the opening plus the slab. I think there is some confusion, I think. You are giving this also, you are giving slab also. That is not correct.
Sir, there is the, I think, cartilage area. No, it's the slab. No.
दोनों नहीं आएंगे ना, एक ही आएगा। यहाँ पे भी आपने वन वे स्लैब दिया है और ओपनिंग भी दिया है, that is not correct. And home sir has marked the slab in this drawing. I don't know who, but he has to be cautious. अपने यहाँ पे भी स्लैब दिया है, ये स्लैब एक्चुअली ऐसे होना चाहिए, ब्लाइंडली फॉलो नहीं करना है। समझ में आ रहा है? स्टेयर केस का स्लैब कभी ऐसे टू वे रहता है क्या? How the staircase goes, it is basically like this, right? It is goes like this. It is like this, am I right? And there are steps here. Am I right? So it goes as a one way. If you see that in the plan, it goes one way like this. Correct? It cannot be like this. Correct, no? And wherever the opening is there, please do not mark the slab. This is not correct. Another thing, as a Mumbai municipality, I told you that you require the shear wall here also. I know that modal analysis and other problems would be there probably, but figure it out how to change it. Is it changing the mode shape if we add this shear wall like this?
Yes, sir. It is.
Yes, sir.
Boss के देगा आपको।
चेक करो, क्योंकि वो फायर डिपार्टमेंट वाला मानेगा नहीं। अगर वो साइन नहीं देगा तो साइन प्रोजेक्ट आगे ही नहीं बढ़ेगा, प्रोजेक्ट विल नॉट बी स्टार्टेड। अदरवाइज व्हाट यू नीड टू डू, you need to give the shear wall here, shear wall here, और यहाँ पे आपको खाली लोड करके वॉल डालना होता है। There would be some small soft joint between here and here, but वो detailing is the issue. Means this one will be the RCC wall, this one is also RCC wall, and this is the load bearing wall. Means the wall will be like this here, the wall also will be like this here, and there will be a beam here, and there will be small joint given here, and here there will be a wall constructed on the top of this beam. There would be a small gap that would be there here and here, small, like a detailing thing, but that creates the leakages and other issues actually. So that's why try to avoid this and give the wall here, and then work with the modal analysis if possible. Understood? This is not the structural requirement, but from the fire department in Mumbai. Same issues here. I think the person who is creating the structural drawing, you need to work a little bit more. One way slab here also. I think here he has given correctly, there is no slab marking, so that is good. Structural column layout, whom sir has created, fantastic guys. Very good actually. This is hardly any mistake is there. See, only thing is over here, I'm feeling like if we can extend this shear wall till the edge of this. Why? Because such a long beam should not be rested on another beam here. Just check if it is possible, because there is a beam coming here, so there is a point load coming from many places, and it is resting on the another beam. So I would suggest that if you can increase this shear wall, so that on the top of that this beam is rested, like this over here. This beam is rested on this beam, and this beam is rested on this shear wall directly. Are you getting everybody? What I'm saying? Okay. Same thing here. This shear wall also can be extended so that the bearing of this beam should be transferred to the wall. I will use the same color which you are using. So shear wall will be till the edge of this. Both the cases, similar cases. See here also it is given properly. And yeah, the framing layout which somebody has done, this is so nice. Dotted line inside, this sharp line outside, both here also you need to see that are you going to give this as a floor beam? If the floor beam is there, yes, both the lines will be coming it as a straight line. Since it's a sunken slab, here you are giving the one way, here it is missing. Correct, please add that. One way, two way markup is missing. Correct, no?
Yes, sir. Yes.
And the small slabs do not give the one-way slab, two-way slab. You can give that as a one-way slab enough. So two-way slab means on the side you need to crank it. Another bar will be like this, and you need to do this. One way means you go straight bars, so it is easier, at least. Okay. Other things are okay. See, another small thing I wanted to tell you. This is the span of the one way. Am I right? This is a very simple thing, but it's very important on the side. So one way slab, you try to give this also one way, no? Even the Ly by Lx ratio is not an issue. See why it is? Because the bar bender will calculate it, what is the length of this, and he will just cut the rebars and just place it like this. I know that this can be two-way, but how much saving you are going to do? Hardly anything anyway. Got it? So these are small tips I would suggest, like this, which is given by you only. It will be helpful to the bar bender to cut the bars. Similarly here also, one way. Even though this slab can be two-way because of Ly by Lx, but we are giving it one way just to make it ease out for the bar bender. Got it? और जिसको ये पता नहीं चल रहा है जरा बार बेंडर के ऊपर अंदर काम करने के लिए प्लीज गो देयर, check the site so that it will be helpful for you to understand. Other column locations and all is very good. Even though there is a sunken slab, give the one way, two way, that is missing. I would suggest that if you can give here one way like this, perfect. But very good, huh? Straight line, dotted line, shear wall numbers, beam numbers. Very good improvement. Even the notches here, so perfect. So perfect. Internal line is straight line. Why? Because there is an opening here. External line. This is internal line, dotted line. Very good. Loading diagram. So nice. Who has created this drawing? This one. Very good ones. This is the improvement. This is ready to, you can, the verge of submission of the tower. The only thing is, instead of bottom tower, just call it as tower 1, 2, 3. Okay. Yeah, can you go to the next slide? I'm not able to. And please clear the annotations. I'm clearing, but it's not going actually. Praveen, are you there? Yeah, I think it's net. Yeah, I think you got disconnected. That's why I'm not able to clear the screen. Yeah, okay. 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 Overall, it is good. Yeah. Keep it like this only, no problem. Or maybe, yeah, you give me the control. Yeah. See, for other guys, please understand how, meticulously this has been done. This is the diagram of the whatever the tower number they are calling, and this is how it is given. So certain general notes are also given here. The only thing is this one way mark is missing, that they will add it later on. But overall, very good, guys. Good improvement. Yeah, next slide. I think it is gone now. Okay. What is the size of the shear wall, the width you are taking? Minimum?
From the still to 15th floor, we have taken 500, and from the 15th to 30th floor, we have taken it as 450, and above it is 300.
Okay, but do you need that much from the design point of view?
Value engineering is not done.
Okay. 150, 200, and headroom slab is 125. Okay. So beams and slabs you are given M30, and shear walls and columns you are given M40. Very good. In the first tower, I have seen that there is a deflection of 3 meters. That is not correct. This is, what is WW meter? What is that?
Oh, so it is the wall width, and you.
No, don't give such kind of norms. Give the wall width.
Yes.
Partition wall width. Don't give, your own nomenclature. Hmm. Even I'm getting confused what you guys are doing here. The wall width is this much. 0.15. Material density means 10. Means you're taking the lightweight block work. Okay. Load to floor height. This minus 0.6. Okay. Then what is this?
So it's
Floor height. This is floor height. Beam height. Okay. And this is what? Unit density. Array, write down this proper here.
okay.
Yeah, see the color combination of this looks little bit more better than this one. This looks a little bit gaudy. Okay, so please make sure that the soothing colors you are giving. Gray color, black color, or maybe the blue color, light blue color. Don't give harsh colors. This comes under a little bit harsh. Okay, from the presentation point of view, I'm saying this looks like old schooling. Don't do that. Okay, so this is the middle tower. These are the loads that you have considered. Okay. Good. Parking you're taking 5, huh? Okay. This is the area load calculation. Okay. terrace flooring. Okay, nice. We have considered area load of 25 kilonewton per meter square for all the towers. What is that? OHT, okay. Lift machine room, okay. Yeah, this shear walls and locations are perfect. The only thing is, I'm not sure. Just figure it out if you can avoid this. Maybe I would suggest that if I take the elevation of this, no, I would suggest that I will give the entire shear wall only like this with the opening here for the windows. Is it okay? Are you getting what I'm saying? Instead of giving this wall 1, wall 2, or maybe pier 1, pier 2, I would suggest that you give one wall only and give the wall opening in between by going to the edit section elevation. Sorry. Got it? The rest, I think it is okay. These column sizes are, I hope those are correct. Okay. Do you need these many columns and shear walls and all? By adding another 5 floors, 45 levels we are going to do, no? Basement plus ground plus 45. So based on that, you just figure it out later on. Height of the building, length of the building. Anyway, these things will change. I think I still remember I told everybody that it is 45-story building.
Actually, at the first stage, we have taken 45, but have asked Titagat sir to how much we should take, and he said that 40 story you need to take.
No. I think directly, if you remember, I told you guys 45. I have forgotten to inform Tathagata actually. I was asking, if you remember that in the sessions also I told you that it is 40 only, but client might construct another 4-5 levels. So which floors that we will consider? We will consider 45 only, no, because that will be even worse in situation. It is 40 only, if you ask me, but he might get the TDR from somewhere else and he might construct maybe 2 floors, maybe 3 floors or something on the top. Maximum 5 floors he will construct. That is what actually client is asking for. The provision they call it as. It means, I'll tell you, sometimes the client may construct illegally also. Are you getting what I'm saying? So all these provisions, so उसने एक फ्लोर कंस्ट्रक्ट किया ऊपर इसके लिए बिल्डिंग गिर गया, ऐसे नहीं होना चाहिए. उसको कंस्ट्रक्ट करना है करने दो, बट बिल्डिंग बाकी के फ्लोर्स में प्रॉब्लम नहीं आना चाहिए. लाइक दैट वी आर गोइंग टू कंस्ट्रक्ट. Okay, so I mean, not in Mumbai it doesn't happen that way, but sometimes it happens. So you need to keep that provision. Okay. So time period you are given. Base shear is 2000 and 2600 kilonewton. Are you sure this much only you are getting? See, if you are calculating it like this, no, I would suggest Prasun and all other guys that whenever seismic weight, don't give only, yeah, okay, this is the seismic weight and this is the base shear. So how much percentage? So VV bar is equal to AH into W, right? So how much is the AH value? So percentage of seismic weight. Horizontal acceleration coefficient is how much? That is very important. So I think it is less than 1%. Correct, no?
Yes, sir.
So how come 1% only we are getting? Let's calculate it here. Z by 2 into I by R into SA by G, right? Z is how much? 0.16 into 1.2 divided by 2 into 4, correct? R is 4. SA by G value is coming how much? How much you are getting? Are you getting so low that it is becoming like 1%, 0.01 only? How much is that? Less than 1% is very less, my dear. I think something is, I don't know.
0.7%.
Huh?
0.7%.
0.7%, no?
Yeah.
Just check. I'm not sure that you might be right also. Just figure it out, this particular figure. I mean, I'm not sure. Such a low percentage for high-rise building. Just figure it out. Have you considered the seismic weight of 0.5 in case of live load when the live load is more than 3?
Yes. Defining not.
Okay. But this is little low percentage of the seismic weight. See, again the color combination. See, content is right, okay, but the color combination, just figure it out. This is this will change a little bit for 45 levels. Yeah, this is something wrong. It has happened in all the 3 columns, tower 1, 2, 3. See, don't give the summation. You give UX and summation separate, because I would be figuring it out what is the individual content, not the summation. So first time period I can understand that it is under UX direction. So ऐसे जा रहा है. This direction the building is deflecting. In UI direction it is there, but it is hardly 0.3%. So that is very good. RZ is also, it is very good. It is hardly 0.05. So majorly this is 5%. So all the percentage is perfect. Even the content is, there is no second thought that it is so nice. Just you add the UX and UI component and summation of RZ component. These 3 things are missing here. Okay, next slide. Color combination is not right here. No, it looks very gaudy. Old school like. Don't do that. Give the very decent colors, guys. Okay. कैसे कलर कॉम्बिनेशन होना चाहिए प्रोफेशनली, जरा यूट्यूब पे गूगल पे सर्च करो जरा, ठीक है. Okay, so base shear due to wind you are getting this much figures. Self weight you don't need to give it for the wind load. So this particular figure you need to give it somewhere here. ठीक है. सेल्फ वेट का और विंड का कुछ लेना देना है नहीं. देयर इज नो रिलेशन बिटवीन द सेल्फ वेट ऑफ द बिल्डिंग एंड द विंड लोड बेस शेयर ऑफ द बिल्डिंग. देयर इज अ ह्यूज अमाउंट ऑफ रिलेशन बिटवीन द सेल्फ वेट ऑफ द बिल्डिंग एंड अर्थक्वेक बेस शेयर ऑफ द बिल्डिंग, बट देयर इज नो रिलेशन बिटवीन द विंड बेस शेयर. अंडरस्टूड? So you should not be writing next to the wind base shear. It looks odd man out. Okay, now coming to the Manish is waiting outside. Who is Manish? Abarna? Acha, aa gaya Manish.
Yes, sir.
Okay.
Yes, sir.
So no, it's okay. Somebody has written. Okay, so WX and WY you are getting 6,000 and 4,000, 6,700 and 4,000 this time. And earthquake base shear इतना कम आ रहा है, earthquake base shear and wind base shear इतना ज़्यादा आ रहा है. Something is wrong. Next slide. ये ठीक नहीं है.
Sir, due to the diaphragm, sir, we have given. So basically, sir, top structure is far away from the sir, global axis, sir. So due to
No, even if it will induce the torsion. No, it will not increase the base shear, my dear. Correct, no? See, what you are asking is, my building is like this and the core is far away from the center. So what it will do is it will create the torsion. It will not increase the wind base shear. Do you agree?
Yes.
So दोनों का relation नहीं है. How does it correlated? You please study, everybody. Okay, so and it's good that you are trying to defend the argument. It's good, but try to figure it out if the argument is having sanctity or not. You are getting the base shear almost 3 times. Seismic base shear is EX. Seismic base shear is 2050 and wind base shear is 6722. Something substantially wrong in the wind calculation, guys. Next slide, please. Next slide. This is okay. Meshing is perfect. Wind analysis, I mean the calculation wise, model wise, I don't think any issue is there. Maximum deflection of the slab. Deflection calculation is fine. Just fine. I think you have done the creep analysis also, or you multiplied by 3. Okay, fine. Go to the next one. Yeah, see, this is something which I was wondering. This is absolutely not correct. Where is it? Something seriously. हमारे 80 G+84 स्टोरी बिल्डिंग को भी इतना लफड़ा नहीं हुआ था, इतना डिफ्लेक्शन नहीं आया था. कुछ ना कुछ तो गड़बड़ है.
सर एक्चुअली जो डायफ्राम जो है, मतलब पूरे पहले एक यूनिट था, पावर बॉटम पावर और लोअर, एक साथ डायफ्राम असाइन किया था, फिर उसको ब्रेक करके अलग अलग डायफ्राम असाइन. तो वो क्या कर रहा है कि जब हम लोग अलग करके डायफ्राम असाइन कर रहे हैं तो वो ग्लोबल एक्सिस के साथ भी एक इसका पॉइंट प्लेस कर रहा है, तो उसके अबाउट वो सारी डिस्प्लेसमेंट वगैरह रिकॉर्ड कर रहा है.
डिफ्लेक्ट 4 मीटर का डिफ्लेक्शन बिल्डिंग के ऊपर, ऑब्वियसली इट इज नॉट सेफ फर्स्ट ऑफ ऑल, एंड इट डजंट जजिंग मी. इट्स नॉट जजिंग मी. अपर्णा प्लीज लुक इनटू दिस.
यस सर, यस सर.
इतना 4 मीटर का हमारे 80 G+84 स्टोरी बिल्डिंग जो दुबई में किया था, उसका डिफ्लेक्शन इससे 1/4 भी नहीं था. तो समथिंग इज रियली रॉन्ग. ओके, मॉडल में जाओ, फिर चेक कर. ये एक्स डायरेक्शन का डिफ्लेक्शन है. कैन यू गो टू द फ्रेमिंग प्लान? गो टू द नेक्स्ट वन. विंड गस्ट है ना एक्स में, तो गस्ट कैलकुलेशन गलत है. समझ में आ रहा है? And wind gust calculation you will be doing for the which model you are doing? Service crack, strength crack?
सर्विस क्रेक.
Service crack, okay. Yeah. Can you show me the mathematical? This is the same mathematical model which you are getting 4 meter deflection almost.
Yes.
Yeah, see what is happening. You are getting wind deflection because of the higher surface over here. Please understand why you are getting. You are having higher surface here and height is there, and in this direction when the wind is getting blown on the structure, you are getting the deflection in this direction. Understood? So what is the thing that if you are giving the shear walls in this direction, it would help you. So which are the shear walls you will give? So depending upon that, you need to figure it out. And first of all, the wind base shear, I'm not convinced basically. See, above the ground you are giving the wind, or are you giving it from the base?
on the above the ground.
So above the ground.
See, there is a basement and all actually, and then there is a ground, right? So above ground you are giving. Are you sure? Check all the parameters. I think there might be certain small error that need to be addressed. Next slide, please. Huh, huh. Yes, this one. Yes. So you have already given good number of walls in this direction. See here, these are all the walls that are going to resist anyway. So I don't think there is an opportunity to give the walls more than whatever you are given. Check the wind load calculation. The gust factor, I'm not sure that is right. Next one. Earthquake deflection is within the limits. And here you give if you add that shear wall, is it affecting? No, not this, the previous one, sorry. Yeah. If you give the shear wall like this, here also there is a opening, right? Lift is there?
No, sir, there is only 4 services and 1 farm.
Okay. So up to here you can give, up to this place. Here also. Check it will help or not. I don't think it will help because the deflection is there in the X direction. And if you are giving the wall in Y direction, how does it help? It won't help much. Just check which location the deflection is coming more. Maybe it is coming somewhere else. So here you can increase some of the wall or something like that. Is it increasing at this edge? Where exactly? Which point? Go to the terrace floor of your etabs model. Okay. And check that which location the deflection is getting highest. Identify that. नहीं तो पता चल गया ये कनेक्टेड ठीक नहीं, ये एक ही जो है वो घूम रहा है इधर उधर. Only one point or one element is. Pardon?
Actually, building rotated rotation is दोनों तरफ से back and forth कर रहा है. मतलब
Slightly it will happen that way. You are right that this side the stiffness is higher, this side is lower. Central core is also, it is not having any kind of this action. Try to give the one shear wall here and you give the wall here only, but with the openings. So this core, I'm doing is I'm increasing the IXX and IYY mathematically. Anyway, you are going to give the beam here, right? So what I'm suggesting is there will be a shear wall, and there will be one big wall, and this will be wall only, okay, with slightly opening here, and here. So it will increase the IXX, IYY of this, correct? Rotational and moment of inertia. Correct? So this full assembly will be belonging somewhere here. That would help you somehow. Just figure it out. I'm not sure. This is okay. Length of the, I think base shear का कुछ गड़बड़ है. Seismic and 3 times difference. At least I have not witnessed it. Gust factor calculation also I'm not sure. See, if the gust factor calculation is coming here, what is the with the coefficient method, have you calculated how much is the wind base shear? With the wind coefficient method. And whenever you are giving, no guys, this kind of slide, try to give the total summation of the wind base shear in x direction how much, and summation of wind in y direction how much. This is y, right? This is x. So how much total कितना है, sum कितना है? I think you are given it in other slide, but on this slide, if you are giving more emphasis, will be given. Here also same mistakes. You need to give ux, uy. Okay. This is okay here. This slide. Other slides are fine. Here you are getting very less amount of deflection.
No,
110.
no, sir. No, sir. That is only static phase. I am mistakenly taken this for the. This is only static.
I think deflection, just check it. Other thing, torsional irregularity. Other, I think the same mistake is happening in most of the towers, I guess. How the this is not correct. There is a column coming there, right? How the release will happen? It will not happen. Same thing here also, if you can give some kind of shear walls. See, if by giving the shear walls, your mode shape is totally getting changed, for example, so you give at least the load of the shear wall here, okay, on these beams, so that certain things can be witnessed, can be done in the model. Or maybe if you are giving the shear wall here, you give the wall here with the opening, so it will be satisfied. So central, the stiffness would be higher, because you guys are facing problem in the deflection, no? That's why. Okay, good, very good. Overall, the presentation quality, all other things are very good. I think serviceability check you have done. Have you done any strength design and value engineering? See, directly from here, you could have gone to, I know that wind deflection is the issue. But once if you go to the strength design, no, you will come to know what are the margins that are there.
Yes.
Aparna, please help them in the wind deflection. I think overall, other than
Yes,
that,
sir.
it is okay.
Yes, sir.
Okay, thank you so much, team 1. Very good, guys. Very good. Team 2. I think 4 teams are there, right?
No, sir. Actually, 4 teams were there initially, but some of the students left. So, Tathagata sir merged them in 2 teams only, team 1 and team 2.
Okay.
Good evening, sir. First of all, I would thank you for giving us the opportunity to work on this project.
अब प्रदीप जी, आपका आवाज ठीक तरीके से नहीं आ रहा है. पुनीत जी.
Good evening, sir.
Yeah.
First of all, I want to thank you to give us the opportunity to work on this project, and I want to thank you the mentors who helped in this project. So this project is located at Bombay. It is a residential building. It consists of basement, upstairs, and ground plus 45 floors. Floor to floor height is 2.9. 43.5 meters. This is the architectural plan. We have considered 3 towers, T1, T2, and T3. The bottom one is T1 tower.
Its length is 42.4 meters and width is 24.03 meters. The new studio tower its length is 32 meters and width is 20 meters. Third is T3 tower, the uppermost tower. Its length is 35 meters and width is 80. This is central line plan. This building length is more than 45 meters, so we have to do the expansion run, and the code we have to use is IS 3414. We have to give expansion run between tower 1 and tower 2, which is the bottom tower. And from now, Akhilesh will.
Good afternoon, sir. This is a structured training plan of Tower 1. Next. This is a structured training plan of Tower 2. Next. And from now, one of them continue.
Hello, Vanam.
Good afternoon, sir.
Yeah, good afternoon.
Construction materials using this reverse and concrete. Next. In this, we consider only a shear wall of 300 and a M45 grade. Next. This is a mathematical model of tower 1 and this is tower 2. Next. These are the end releases for tower 1 and this is for tower 2. Next. These are the support conditions, fixed supports considered for tower 1. These are the conditions for tower 3. Load calculations for wall loads, for outer wall loads, and for terrace. Next. And for terrace and interior walls. These are shell load calculations. Dead load and live loads are calculated as per IS 875 part 1 and part 2. Next. Analysis considering this: earthquake analysis, wind analysis, and model analysis. Earthquake analysis, static and dynamic earthquake analysis. In static, these are the results we have got for tower 1. This is the base shear for tower 1, 4,000 and in a EX direction and EY direction 5,000 feet. Next. Dynamic earthquake analysis. Dynamic earthquake analysis is scaled as per static. Next. Wind load parameters. For analyzing wind loads. These are the wind load parameters. And next, Sparsh will carry on.
Good evening, sir. So moving on to the model analysis of tower 1, we got the time period of 5 seconds and rotation is 0%. The participation of the third mode is more than 70%. So, and in the last mode, 12th mode, we are getting participation more than 90%. So next slide, please. So the fundamental time period should be greater than 4.5, 0.1, but it is well within the limits. As if we consider 30% more, it is less than 6 only. And the same thing, the third mode is contributing more than 70%, and the last mode is contributing more than 90%. For the first mode is in the translation mode, and rotation is 0%. Next slide, please. So moving on to the stability check of uncracked model. So interstory drift ratio, the wind deflection and the earthquake deflection is well within the safety criteria. Maximum seismic allowable seismic deflection is 571, and in uncracked model we are getting around 193. So next slide. Yes, moving on to the service model of the tower 1. These are the stiffness modification factor which we have used for which we have taken from IS 81893 2016 and IS 16700 2017. Next slide, please. So in the service model, these are the static and dynamic base shear. After scaling, we got this scale factor as 18,000 and 20,000. And next slide, please. These are the wind gust load. After calculation, we got this load. The maximum wind load which we are getting is in X direction. This is from still to 21 floor, and in next slide, we'll get from 21 to HTLMR. The maximum deflection in X direction is 245.63 kilonewtons. And next slide, please. In stability checks for service model, the interstory drift ratio is less than 0.004, and the deflection due to wind effect is coming around 1 to 221.11, and it should be less than 285, and so it is well within the limits of wind deflection, and earthquake deflection is also well within the limits. So next slide. Thank you so much.
Okay. See, overall confidence of Sparsh yourself is good. Okay, but certain presentation slides and all actually are required to be. You need to work a little bit more. Okay? There are some basic mistakes about the structural framing plan also are there.
Yes, sir.
Can you go back to the first slide? First few slides. Yeah, just wait. Yeah, here also the same issue. You know, the podium floors and the few things which I have told regarding the first group. I think certain things are same for you guys. Okay, so I will not be repeating those areas. But at few areas, I found out that structural framing plan issues. There is expansion joint tower 1 and tower 2. Construction materials. Okay, section properties also you are given here. All shear walls are 300 mm.
Yes, sir. I'm 45 grade.
Okay. Generally, I'll tell you the grade of the concrete should be +2. Here and here it has to be +2. So M30 here, M40 here, M40 here, M50 here, like that. Okay, it should not be M30 and 60, something like that.
Okay.
But if you required, let's say M60 here in the shear walls, you cannot go to the M40 here. You have to go for M50. 2 grade down, 2 grade up.
Okay, sir.
Okay. There is a huge amount of literature given in the ACI code that is governing in this area. So, okay, here T2 tower. Yeah, this is the one which I wanted to see. Here you are given both the sides as the releases. That is not true. That is not correct.
Yes, sir.
Is okay. I think one area I have seen that the structural framing plan is not correct. I think tower 1, some other tower. बहुत ही basic बनवाया है. See, I think many people have worked the design of this. Look at this design of this slide, design of this slide, design of this slide. Some issues are there. Okay. Another is one common sense I would like to tell you that I'm more interested into this content. Am I right?
Yes, sir.
Not this, not this, not this, not this. Huh? So always remember the content should be so big, good enough, the big enough. And what is the sanctity of this? क्यों लिया है? Sanctity of this. Why you have taken this, Lord? That also you could have easily added. इतना बड़ा जगह नहीं चाहिए, क्यों देना है? सिंपल, यूज कॉमन सेंस. एक ही स्लाइड में, ओ माय गॉड, एक ही स्लाइड में बहुत सारा इंफॉर्मेशन देना जरूरी है, इंस्टेड ऑफ adding so many slides and having some garbage data. Okay, this is the common sense. This is the first slideshow you have done. Content is very good. General loads, staircase load, and all other things which you are given here. Content is good. Okay, no doubt about it. But these are small things. Yeah, earthquake analysis, static dynamic analysis. Generally ठीक है अभी. ये ऐसे प्रेजेंटेशन में ऐसे नहीं डालते. These are very basic. जैसे कोई लिटरेचर लिख रहे हो और ए बी सी डी पहले वॉवल्स, ये वॉवल्स है, ये वर्ड्स है, ये ऐसे लिख रहे हो, ऐसे लग रहा है. ठीक है, जब भी प्रोफेशनल इसमें जाते हो आप, तो व्हाट टाइप ऑफ एनालिसिस दैट यू आर डन. डोंट गिव ओनली अर्थक्वेक हियर, स्टैटिक डायनामिक, नो, नॉट लाइक दैट. व्हाट यू कैन डू इज लीनियर स्टैटिक में क्या किया है, नॉन लीनियर या क्रीप एनालिसिस ये किया है. We have used the static analysis, dynamic analysis, and the scale factor, response spectrum method use किया है. Like that information, if you are giving, that will be better. Okay. Yeah, this slide is good. Earthquake base shear 4,000, 5,000. I think there is some kind of serious mistake. In the previous case, 2,000, 2,300 something base shear was there. I don't know. So Aparna, please check the base shear calculations. I think most of the cases
Yes,
there
sir.
are some issues,
Yeah,
I
yeah.
guess. Time period calculation also in the first case, I don't know how much time period was there. First group was 3. 3 point something, right? So see, 45 levels, if they are there, you can go up to 4.5 to 5 seconds. Like these people have gone. Okay, this is the suggestion for the previous. I think you have gone for 500 wall, then you have gone for 400, then 300. So you can do some kind of value engineering there, which is already done here by this team 2. They given 300 walls, and that's how they have achieved the time period which is in this zone, which is more appropriate. Okay, team 1.
Yes, sir.
So first mode you are getting UX direction, then second mode UI direction you are getting 10% this thing. So very good actually. Model wise you good. Model analysis. So stiffness modification factor you are giving only for slabs. You are not giving anything for the shear walls and spandrels.
For service,
स्पैंड्रल भी बीम ही होता है ना?
yes, sir. I think we need to edit here. We have not used spandrel.
Something is wrong here. Just figure it out. See, slab if you are giving 0.35, beams you are giving 0.5. This is for service, right? First of all, ये किसके लिए दिया है उसका रीजन ही नहीं पता चला. Where is the service? The word service, right?
Yes, sir.
Service is missing. सॉरी पेन नहीं चल रहा actually. The word service is missing, and whenever you are giving spandrel is nothing but the beam only. So whatever the beam stiffness modification factors are there, that will come here. Hmm? Overall is good. Wind deflection again check it. I don't know the wind base shear कितना है वो लिखा ही नहीं किधर भी. But you are getting the wind against deflection is to 285 mm, which I am happy about. But इतना फर्क
285 is the limiting criteria. We are getting 221.
221, okay. But the previous group and this group, there is a difference, huge amount of difference. I think model wise and presentation wise, team 1 is good. But fundamental wise, team 2 is good. Okay, so we have to have the perfect balance. फंडामेंटली यानी 300 mm जो टाइम पीरियड का कैलकुलेशन है, काफ़ी सारी जो चीज़ें हैं, ऑप्टिमाइजेशन है, वो काफ़ी सारे दिया है. आई थिंक दैट कैन बी लर्नड बाय टीम 1 फ्रॉम टीम 2. वेयर एज प्रेजेंटेशन जो आपने बनवाया ना टीम 2, यू कैन लर्न इट सर्टन थिंग्स फ्रॉम द टीम 1. And anyway, I have given certain suggestions to both the teams.
अर्निंग चाहिए तो लर्निंग करनी पड़ेगी, ज्यादा अर्निंग चाहिए तो ज्यादा लर्निंग करनी पड़ेगी. और लर्निंग के लिए ई-कंस्ट्रक्ट मास्टर स्टडी ऑन जॉब प्रोग्राम्स है ना. अगर आप सिविल इंजीनियर है और अगर आपको कोर टेक्निकल प्लेसमेंट चाहिए सिविल इंडस्ट्री में, तो ई-कंस्ट्रक्ट के ऑन जॉब फुल टाइम ऑनलाइन और ऑफलाइन ट्रेनिंग प्रोग्राम्स को ज्वाइन करके आप सिविल इंडस्ट्री में अपना पहला कदम रख सकते हैं. तो आज ही ज्वाइन कीजिए मास्टर स्टडी लर्निंग प्रोग्राम्स एट ई-कंस्ट्रक्ट.